this type of question, it's often best to start with a free body diagram. So let's draw our elevator, and actually I'm going to make it a little lower. Elevator, and then we have force of tension in the cable going up, and we have a force of gravity going down. Now, ultimately in this question, we're looking for the force of tension. The force of gravity, it doesn't matter what the elevator is doing, it always remains a constant value. It's dependent on the mass of the elevator and who's in the elevator. So the tension changes depending on whether the elevator is accelerating upwards, accelerating downwards, or moving at a constant velocity. So let's look at our givens. And again, we're going to take the approach where we're going to use variables instead of actual numbers. If you're given a question with numbers, you can just replace the numbers inside the variables and you'll get the answer quite easily. So what are we given? Well, we know that the elevator itself is accelerating with acceleration A, and that's in meters per second squared, up. So if the elevator is accelerating down, then the value will be negative, whatever the acceleration down is. We know that the elevator has mass m, and therefore the force of gravity is equal to negative mg newtons up, which is the same as mg newtons down. And with all force questions, we should write an Fnet statement. So our Fnet statement is Fnet is equal to the force of tension plus the force of gravity. So this is simply saying the resultant vector is the sum of these two vectors. Now let's make our substitutions here, and by substituting we're including direction. So first thing, we're going to expand this using Newton's second law. Fnet is equal to ma, which is equal to the force of tension, which is ultimately what we're looking for, minus mg. Now we'll solve for ft, so I'll bring the mg over to the left. We get ma plus mg is equal to ft. Now if we factor this, we get m times a plus g, and that's equal to ft. So our tension force is equal to our acceleration in meters per second squared plus our gravitational acceleration in meters per second squared multiplied by our mass. Now let's see if this makes sense. Let's assume case 1. So case 1 is the elevator is either going up or down at a constant velocity. And if that is the case, then our acceleration is 0. If our acceleration is 0, that means that these two forces must be equal to each other. Because according to Newton's law of inertia, if something is not accelerating, that means there must be, all forces must be in balance with each other, and therefore your net force is 0. So if that's the case, let's throw in a equals 0 here, so this will go away. And if that's the case, just by looking at this equation, we get ft is equal to mg. And that certainly seems, that means that these two forces are equal to each other. So that holds. In the second case, let's say that we want our elevator to accelerate upwards. So we want our acceleration to be greater than 0. Well, if that's the case, then that means that this number here, ft, is going to be larger than fg. And that makes sense too, because this one has to be larger than this in order to accelerate the elevator upwards. Again, that's a combination of Newton's first and second law. And in the third case, what if the elevator is accelerating downwards? Well, if the elevator is accelerating downwards, that means A is negative. And if A is negative, that means that this value is going to be smaller than g, and this whole thing is going to be smaller than Fg. So that means our tension force is going to be smaller than Fg. And that makes sense too, because the force of gravity will be winning. It'll be a longer vector than Ft, and therefore our net force will be down, and that means our elevator will be accelerating down. Now that brings up another interesting point. Even though the elevator is accelerating down, it doesn't mean that it's going down. The elevator could be going up and then still accelerating down, which means that it's decelerating as it goes up. Similarly, if we're looking at case 2, the elevator could be accelerating up, but it could be going down. For instance, what if the elevator was coming to rest as it's, let's say that it's slowly going down to the ground floor and then it decelerates. Well, that means that the tension force has increased and it's allowing the elevator to come to rest. So you have to be careful when you think about acceleration. Acceleration doesn't necessarily mean the direction that it's moving. It just indicates the direction of the acceleration.